Welcome viewers. In this video we will see the hexadecimal to octal, hexadecimal number system to octal number system. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic hexadecimal to octal. So this is coming under grouping techniques. Grouping technique means octal number means we need to group into 3 digits. Hexadecimal mean we need to group into 4 digits. As a binary number should be grouped as 4 digit in case of decimal, 3 digits in case of octal. And also this hexadecimal number first converted into binary, from binary we can convert into octal. So there is a two-stage conversion. Hexadecimal to binary, binary to octal, that is only possible. So first we will see this is a hexadecimal number given 47. First we will convert this hexadecimal number into binary. How will we convert this hexadecimal into binary? This 47 is written separately, 4 is written separately and 7 is written separately. We need to convert this 4 into binary, 7 into binary and written in 4 digits. This is called a grouping techniques, 4 digits. We need to group into 4 digits, right? So first we consider this hexadecimal number will convert into binary. This 4 written separately and 7 written separately. Now we will convert this 4 into binary, is available here 4. How to convert? By dividing. So 4 is divided by 2, it goes 2 times, balance 0. 2 is divided by 2, it goes 1 time, balance 0. So write in a reverse order 1 0 0 1 0 0. That need 4 digits are needed. So write one more 0 in the MSB. So it is 0 1 0 0. The given number 4 is converted into binary here. So that is 0 1 0 0. Now convert 7 into binary. 7 is divided by 2, it goes 3 times, balance 1. 3 divided by 2, it goes 1, balance 1. So write in this reverse order 1 1 1, right? Triple 1. But what we need is 4 digits are needed. So add 0. Here adding 0 is not a much more effect because it is MSB. But here adding 0 is must. Otherwise, while combining these two, the value will change, right? So we need to add 1 0 here. Already only 3 digits are available. We need to make another digit as 0. Now we can combine this 0 1 0 0 0 triple 1, right? So while combining this 0 having more effect, right? If the 0 is not added, the value will change. The 0 must be added. We will make it as 4 digits, right? So this 47 now converted into binary, combine this 0 1 0 0 0 1 1 1, right? Now converted into the binary system. Now we need to convert this binary into octal, system. So what is that octal? We need to group into 3 digits. I already told the grouping technique means octal means we need to group 3 digits. The converted binary number is grouped into 3 digits, right? From LSB. From LSB we need to convert into 3 digits. So here 3 ones are available, 3 ones. Then 3 zeros are available. Then 1 0 is available, 1 0. Add one more 0, right? So it is 0 0 1 triple 0 triple 1, right? So converting binary to octal from LSB side, we need to group it into 3 digits. If the digits are lesser, add 0, right? So the given binary number is grouped into 3 digits. Now each and every 3 digits should be converted into the octal number. How it is? By using this weightage 4 to 1. What is 4 to 1? 2 to the power 0, 2 to the power 1, 2 to the power 2. 2 to the power 1 is 2 to the power 0 is 1. 2 to the power 1 is 2. 2 to the power 2 is 4. Right? So based on the weightage, this 4 to 1 is nothing but 2 to the power 0, 2 to the power 1, 2 to the power 2. 2 to the power 0 is 1. 2 to the power 1 is 2. 2 to the power 2 is 4. Right? So directly we are using this weightage 4 to 1. Right? So we need to compare these digits. Here all ones are available. So 4 plus 2 plus 1, 7. Right? If the digit is 0, we no need to consider the weightage. That becomes 0. Right? So 4 plus 2 plus 1, 7. Here all zeros are available. All are 0. So it becomes 0 only. 0 into 4 plus 0 into 2 plus 0 into 1. All are 0. Here only 1 is available. First two digits are 0. So this 4 and 2 become 0. Only 1 is available. 1 into 1 is 1. So what we got? 107. So this is nothing but a octal equivalent. 107 base 8. Right? It is the how we converted group 3 into 3. Each and every 3 digit is converted into octal and all these 3 are combined together. Right? So finally we got this answer. Right? So this is the hexadecimal number given, that is converted into binary. How we converted? 4 is converted to binary, 7 is converted to binary, written in 4 digits, then combined together. Then binary is converted into octal. How it is? The given binary number is grouped into 3 digits. Each and every 3 digit is converted into octal by using this weightage 4 to 1. When the digit is available 1, then we can add. If the digit is 0 means all are 0. Here 2 zeros are there. So 4 to 0, only 1 is there. 1 plus 1 into 1, 1. Then write the final answer. Right? So hexadecimal is converted into binary. Binary is converted into octal. So this is the final answer. 107, the base 8, octal number 107. Now we'll go to the second example. One more example, we'll see that A7B9. The given hexadecimal number is A7B9. So that should be converted into binary. From binary we can convert into octal. So indirect form. These are two stages available. First we will go to hexadecimal to binary. What is hexadecimal? How will you convert hexadecimal? Write these 4 digits separately. A7B9. All are written in separately. A7B9. Right? So the A7B, what is the A value? In hexadecimal we have the up to 0 to 9 as it is decimal. From 10 onward, 10 is nothing but A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F. Right? So that A is nothing but 10, then 7 as it is. B is nothing but 11, 9 as it is. Right? So the given hexadecimal number, each and every digit is written separately. A is equivalent to 10, B is equivalent to 11. Now we need to convert this each and every digit into binary and written in 4 digits. I already told grouping techniques, hexadecimal means we need to convert into 4 digits. First consider A. A means 10. The 10 is converted into binary. 10 divided by 2. It goes 5 times, balance 0. 5 divided by 2. It goes 2 times, balance 1. 2 divided by 2. It goes 1 time, balance 0. Write in the reverse order. 1 0 1 0. Right? So the binary equivalent of A, hexadecimal A, that is 10 is nothing but 1 0 1 0. Now take the 7. Right? Hexadecimal number 7. Right? 7 divided by 2. It goes 3 time, balance 1. 3 divided by 2 goes 1 time, balance 1. Right? Write in this reverse order. 1 1 1 triple 1. But we need to make it as 4 digits. So add 0. It's must. Right? If 0 is not added, while combining the digit, the answer will be different. Right? So the 0 is added here. 0 1 1 1. 0 triple 1. Right? Then B. B means 11. Take 11. Convert into binary. 11 divided by 2 is 5 time it goes, remaining balance 1. 5 divided by 2. It goes 2 time, balance 1. 2 divided by 2. 1 time, balance 0. So 1 0 1 1. The 11 is nothing but 1 0 1 1. Already it is in 4 digits. Then take the 9. 9 divided by 2, 4 times, balance 1. 4 divided by 2, 2 times, balance 0. 2 divided by 2, it goes 1 time, balance 0. Write in the reverse order. 1 0 0 1. 1 0 0 1. Right? Now each and every digit is converted into binary by dividing 2 and make it as 4 digits. Here all are 4 digits, only here we have 3 digits and make it as 4 digits. Right? Now combine all these value. That is the binary equivalent. 1 0 1 0, 0 1 1 1. Suppose if you are not added 0, this value will change. Right? So 0 1 1 1, then 1 0 1 1, then 1 0 0 1. Right? Now hexadecimal is converted into binary. Now this binary should be converted into octal number. How it is converted into octal number? So octal number means we need to group into 3 digits. This given binary, this converted binary number should be grouped into 3 digits starting from LSB, not from MSB, starting from LSB. It is, see this 100 is the first 3 digit, then 111 second digit, 011 third one, 110 is fourth one, then 010, right? Finally one 1 is there, 1. So make it as other 2 zeros, right? From LSB on LSB side, starting from LSB side, this converted binary is grouped into 3 digits. All are 3 digits, right? These 3 digits now will convert into octal by using the weightage 4 to 1. I already explained 2 to the power 0, 2 to the power 1, 2 to the power 2, right? Simply we wrote 4 to 1. We need to multiply this according to the value 0, 0, 1. Only 1 is available. Only LSB is 1. So this 1 will be there. This 4 and 2 become 0, right? The final value will be 1. Here all are 1 available. So 1 into 4 plus 1 into 2 plus 1 into 1. So 4 plus 2 plus 1, 7, right? All ones are available. Here only first and second digit available. Third digit is 0. So this 1 becomes 0. Only 4 plus 2 is 6. Here second and third digits, that is 2 plus 1, 3, right? Second and first digit is 0. So we need to add 2 plus 1. Here only center, the center digit is 1. So the center 2 will be 2. This 4 and 1 is 0. Here the last digit 1 is there. So this 1 will be 1, right? So according to the value, if all ones are there, mean we need to add 4 plus 2 plus 1, right? If the any digit is 0, that corresponding weightage will be 0. Here only 1 is there, mean 1. Here first 2 digits are there, mean 4 plus 2, 6, right? Now combine all this value 1, 2, 3, 6, 7, 1 base 8. So this is nothing but the octal equivalent of a given hexadecimal number, right? So this is the hexadecimal number first converted into binary. Each and every digit is converted into binary and make it as 4 digits. Then this binary number is grouped into 3 digits starting from LSB. Every digit, 3 digit is converted into octal and then combined together. So this is the final answer, right? So in this video we discussed 2 examples for converting hexadecimal to octal. So we can convert hexadecimal to binary and then binary to octal. 2 stages are available. Other conversion technique also given in the separate video. Details are available in the description box. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.